Are you doing okay with me? Can I call you a blood? Or would that be like first and issue? First and
Call me what?
can I call you second one are both right. And
blood?
Yep.
That's the text.
You're on my track. All right, Evan.
She asked me, can she call me blood?
You said you should have a number,
Not quite.
Not quite.
Not quite.
This one's right. This one's right.
Keep messing with me.
This one is
I'm gonna
not.
find you.
Your denominator's not quite right. Is it 5? That's still not right. So look at this first fraction, right? 30 over 100. 10 goes into both of them. Does 20 go into 30? Exactly. And then look at that one. See if it would be the same. You get a 2 neck now? You still don't understand?
Bro, he asked about
Do it gotta be the same? It gotta be the same?
Yeah. And then simplify that one more time. You got it. You're on the right track.
Oh, maybe don't. You got something but you got dead. I never heard that.
Not seeing much writing on the
You can
paper.
go anywhere you want to say. I'll take you dead.
You have a control?
Right here, this.
Why does everything be written?
Everywhere on your head. Unless it's like your jaw.
Alright, I want you to write along with me whenever we do the first one on the board. I want to see that you have work written. Okay?
Is this New York?
You want to write something down? So we know
What it is?
fractions, right? So, they're both even numbers, right?
Hey, you know what city this
How
is?
many times? Yeah.
This bird.
Two go into 25. 12. So yours is
She reminds me of the
so then how can you show
what's
that?
that cartoon show, The Magic School.
Oh, she knew.
No, it was last week. I think on Friday. She had a hair like hers. She had her glasses on. She was like wearing like a dress. She looked like her. So then Rita says, what's your name?
12.
What's your name? What is she, Italian?
You guys talking about me?
Are you Italian?
I am.
No, you're not.
Just saying. Alright, you guys, attention back up here. We're going to go over these. There seems to be some confusion. I'm sorry? That's okay, that's what we're working on. Alright, you guys. So, if my directions were unclear, I apologize. What's that? Okay. What we wanted to do with these examples was take each fraction and simplify it to its simplest form individually to see if the two fractions were the same. Okay? So if we look at the first one, and if you guys don't have any notes written on your page, if you were really confused and you didn't get how to do this, please write this work down because it's going to help you throughout the rest of the lesson and in your independent practice. It's only going to help you. So the first one, what do we have? 24 over 6? Okay, so when we want to simplify this, we want to try and get it so that these numbers no longer have a common denominator or a common multiple. So if we look at 24 and 6, we know that they're both even numbers, so they're both going to be divisible by at least 2, right? You can, yeah, you can jump right to 6. If you divide each of these numbers by 6, 6 goes into 24 4 times, and 6 goes into 6 once. So this is your simplest form of the first fraction. So then the second one was 12 over 3, right? How many times do these have a common multiple? 3, right? How many times does 3 go into 12? 4. How many times does 3 go into 3? 1. So you can look at that and they're the same fraction. This means that they're proportional fractions, right? They're proportional ratios. Let's go on to the second one. We'll do it over here. We had 30 over 100.
10.
10 goes into both of them, right, T? 10 goes into 30. How many times? 3. And into 100? 10. Awesome. And then 60 over 200. 10 goes into both of those too, right? How many times does 10 go into 60? 6. How many times does 10 go into 200? 20. Is this simplified all the way? No, we can keep going. These are both even numbers, right? So 2 will go into both of them. Whoops. How many times does 2 go into 6?
30.
How many times does 2 go into 20? 10. Look at that. We have another pair of proportional fractions. All right? Does that make sense to everybody a little bit more?
Yeah, I get what you're saying.
Okay. Thank you, Nick. All right. So, from that, I want you guys to take a look at the pictures of the city that you see on your desk. That city is Pittsburgh, which is my hometown. The big black and white pictures of the city.
No.
For the next 2 or 3 minutes, I want you guys to talk in your table groups and answer these 4 questions about the pictures of Pittsburgh, okay? If you want to write down your answers, you can write them on like the bottom half of that sheet there. If you want to just talk about them, that's fine too. I want you guys to have something prepared to answer each of the 4 questions.
How pretty.
What's that?
Y'all chose pretty. Why they the same?
What's the
Go out those questions.
Same size.
What similarities do they have?
Yeah, same place.
They both show
The same picture or the same shape?
Yeah.
They're both rectangles. Yeah. They have the same measurements. If you were to take your measure or your ruler and measure those, would they be the same? No. If they're not the same size, how did they get the same picture?
Because the printer might be like, I don't know, something wrong with the printer or something.
Nothing's wrong with my printer.
If so, why are they different sizes? We don't know. Because it's the paper, and you can't determine what you put on the paper.
Okay, that's fair.
Oh,
But I'm talking they just
About
if
like
they're the same
measurements.
image. Why are they different sizes? One has a longer length and one has a shorter length, right? That would answer that question. They're different sizes. One has a longer length, one has a shorter length. But they're the same.
Not really blurry. More about
You guys, have you thought of anything different in mind?
like different shapes.
Bigger than that? Smaller or bigger?
Like there was stretch.
That's distorted.
They're
Let's pick up
distorted because you
Stretched
print
out.
it.
Yeah, distorted.
Bigger image, bigger. Smaller.
If I were to
Same image.
distort
Why
it,
is that one like
it could come
all distorted?
Do you know how like when you're taking a picture, like drawing like
This year, that's what we're
like,
doing.
Like if I zoom in?
like if you're like resizing it.
Yeah.
What about you guys?
Like if I zoom in or something like
Well, for
that.
one, the similarities
Yeah,
they
it's
have,
hard.
they're both same pictures and they're both
It was like a
rectangles.
backwards.
Alright.
Do they have the same measurements?
That's Mr. Mitchell,
One is smaller than the other picture, smaller than the other.
Okay. All right, you guys. I'm gonna have you refocus back up here, and we're gonna answer these as a class. Isaac, can you tell me one thing that your table talked about that are similarities that the pictures share? They're the same picture. Do they show all of the same stuff? Is there stuff cut out of one picture?
Yeah, no.
No. It's the same thing.
They're the exact same picture?
Yeah.
Keenan, can you tell me something that your table talked about for question number 2? Did you guys talk about anything for question number 2? Nick, can you help him out? What did you guys talk about? So why are they different sizes? What makes them different sizes?
You printed in their way.
Yeah, but if, like I said, if you were to take your ruler that Miss Weldon gave you guys and measure them, what makes them different?
The measurements.
Right, so they don't have the same measurement. One has a longer measurement. One has a shorter measurement. T, why aren't they the same size if they show the same image? Why aren't they the same size if they show the same image?
Because the measurements are different. I don't know.
That's good. That's good enough, yep. Lizzie, do you remember why we talked about why aren't they distorted? No?
I didn't even write it down, to be honest.
That's okay. Nicole, do you remember?
You got 30 how many? Hell yeah. I got like 45.
Corbin, what about your table? Did you guys get anything for question number 4?
Nah, we don't even know what distorted means really.
So distorted means like if you look in a funhouse mirror and your neck looks like it's like 5 feet long. Yeah, like stretched out. So if the second picture is bigger, why isn't the bridge like stretched out and long?
Like zoomed in.
Okay. The term we want to use there is that they're proportional to each other. Okay? So that's one of our terms here on the front of your note packets. The images are proportional to each other. Okay? So one is bigger, one has longer measurements, and one is smaller and has shorter measurements. But if we were to simplify them like we did in our do now, we would get the same simplified ratios. Okay, so let's flip over our notes and we'll go over what we're going to learn today. So we're going to apply this knowledge of proportions to triangles, and we're going to talk about how triangles can be proportional to each other using 3 different theorems, or like 3 different rules. Okay? So first theorem, and I want you guys to fill in your notes in the chart. The first theorem is side, side, side. You guys should be filling these in your notes so that you have them. On the back of the first page, there should be 2 charts. We're on the top chart.
The next one is side angles.
We're on the first one, guys. So the theorem side, side is basically saying that if you have 2 triangles with proportional sides on all 3 sides, then the triangles will be similar. Okay? If all 3 of the side lengths are proportional to each other, your triangles will be similar to each other. The example in your notes. The example in your notes has these markings that show us the sides are equal to each other. Okay? Sometimes we won't get those easy markings. Sometimes they'll be giving us numbers, and we're going to be setting up fractions like we did in the do now. Okay, so the next theorem, if we look down, I think someone already shouted it out, side, angle, side.
Yeah, that was me.
What's that?
So that was me.
Nice work.
Yeah.
Side, angle, side. See, if you knew it, can you explain it?
When I learned it, I looked at the side, I looked at the angle, I looked at the side again.
All right, that's pretty basic.
No, can I do it? I know what it is.
What is it, Corbin?
I can do it. Good job.
Do we write it in the same box?
You're writing in the second box on your chart now. So the second
That's
theorem,
what I said.
this one here. Chris, can you write these in your chart?
What's that name say?
Alright, so this and then that. That and then that. Right?
That's right. All right, so like Corbin showed us, when we have two triangles that have two legs that we're told are either equal or proportional to each other, and the angle in between those two legs is also equal, that proves to us that that triangle is similar. I know, guys, stay with me. We're almost done. The last one we're going to talk about, angle, angle. And this is going to go on the third box in your chart. Right? Not for today. Today we're just learning these three basic ones. You guys will be learning about this all day tomorrow too, so it's just like a little intro.
I did this. It wasn't such thing as angle.
Yeah.
No, there's such thing. I can't take credit for coming for this.
All right, guys. So when we're given two triangles and we're told that they have two angles that are equal to each other, that proves to us that the two triangles are similar to each other. What if you had this triangle and this triangle? Are those triangles similar?
Yeah.
Why?
Yeah. It's proportional.
It's proportional. But what about the drawings on these two triangles tells you that they're
The angles.
similar? Right. And the angles are going to be the same no matter what the lengths of the sides are. Right? All right. Another table activity for you guys. You should have a little triangle and a big triangle in colored paper on your tables. To fill out our second chart, the bottom of your pages, the second chart, where it says redraw everywhere, I want you guys to take the triangles on your tables and manipulate them so that you can see the triangles lined up nice and neat and side by side like they are in the upper left-hand box. All right? So like when you're given two triangles and asked to see if they're similar, they're not always going to be nice and side by side and look like the same triangle like these ones on the board. Right? Sometimes they'll be rotated or twisted or flipped upside down. Right? So how would you redraw this triangle here to make it look like that one?
Just
So you want
rotate.
this triangle to look like that triangle.
Rotate.
All you do is rotate it. But you have to keep track of which lengths are proportional to which lengths, right? So now that you've redrawn that one, draw your congruence symbols of which lines are congruent to each other. Do you know what I mean? So like the shortest lines, they're gonna be proportional, right? These diagonal lines, they're the ones that are gonna be proportional. All right. You guys redrawing those down there? So you don't want to redraw them like that. You want to redraw them so they look like they're the same triangle, like that. What's that? So you want to redraw them so that they look like this. You want to orient this triangle. You want to rotate it, right, so that it's right angle. Right, exactly. We'll go through some of these together after we fill out our charts. So, this one and this one. you don't want to redraw them to look like that. You want to redraw them so that you can see the two triangles as if they were the same picture. So like this triangle looks different from that triangle, right? So you want to redraw it and like, nope, you all got the same papers.